Hey, what's up, guys? How's it going? I'm filming this video here, taking you through slides 8 through 12. Slide 13 is just your reflection. So, anyways, we'll get to this one in a second. We're going to look at the fabric and the adult to child masks constraints. And we're trying to figure out, right, solve for that little point of intersection because we're really interested in the corners of the feasible region. He can make that many masks down there. Looks like he can make 14 as well, if we're totally right on that. 14 masks given the fabric constraint and given the adult child masks constraints, just 14 adult masks. But the question is, can he make 10 and 5 of the child masks? It's a very similar problem. Just remember those constraints for the fabric and the elastic were very similar. Okay, so anyways, just going back to this here, solving for that particular point there is similar to how you solved for the point given the elastic constraint. So I'm back here on slide 7 right now. If you need to slow down for a second, maybe pause it, gather yourself here, because I'm going to go for this right now. So maybe you read it first and then we'll go over it. So anyways, the idea is you want to find the point. Remember, the border line is a line. These are equations, right? We got to change these to equations to get them. And I know there were slightly different constraints. We had the elastic constraint earlier, so we switched it to an equation. We switched the adult to child mass equation. Then we wanted to figure out where those two lines crossed, right? A lot of people said that corner of the feasible region is a very interesting point. It might tell us the most child mass and adult mass if you wanted to mix them two to potentially make. And he got close to being able to make 15, given the elastic and the child to adult masks constraint. Didn't quite get to 15 though. Okay, so just a quick recap on what I showed you earlier. Solving a system. This is called a system of equations, okay? What is a system of equation? A system of equations is a group of two or more equations. Here we have equation number 1 up top, equation number 2 right here. Remember, those are just the equations of the border lines. The system of equations is two or more equations that share the same variables, okay? And what you can do with those two equations is you can use some laws of math and some reasoning to determine what common solutions would exist in both of the equations. And what we would call that is the solution to the system after all, which is where the two lines intersect. That point there would be an A value and a C value, or an X and a Y value, right? That's how Desmos reads it. That would satisfy both of these equations. Okay, so just quick recap on how you do this. It's why you do this. Quick recap on how you do this using the substitution method. If we know that A, okay, here I got A, it's right there. If we know that A equals 2C, then we can take 2C. Right, we can take 2C right here and plug it on in for A, right? Plug it on in for A into equation number 1, okay? So step 1 to solving for substitution method, substitute what you know about one of the variables from one equation, right? This variable equals 2C, right? They're equivalent to one another. That's going to give us our borderline of the adult to child ratio constraint here. Okay, so replace 2C, replace A with 2C here. So take what you know about one variable, replace it in the other equation, okay? So I'm taking what I know from equation number 2 and plugging it into equation number 1. So here I got 14 times by 2C plus 12C equals 198. That's nice here. Claire earlier in class said, hey, no good. We have two variables here. Now we got one variable. We can solve for that variable, okay? So 14 times 2C, 14A, and A is just equal to 2C in that borderline. Double it, right? Double the 14, right? So we do 14 times 2. That's equal to 28. Still got that C hanging out, right? That's how we simplify with variables here. 14 times by 2C is 28 Cs. Then we got the 12C here, plus 12C equals 198. Add the two together, we get 40. You just got to solve here, okay? 40 Cs could get us to 198 elastics, right? If we had 40 child masks and we have 198 elastics to work with, sorry, not 40 child masks. If we have a certain number of child masks, and that's going to, anyways, it's getting confusing. It's the word problem. So whatever, I got 40C equals 198. I'm going to divide both sides by 40. And I got C equals 4.95. So that point where they would intersect here isn't going to be a valid thing for our situation because we need whole numbers of masks here, okay? But anyways, the equation says we can make 4.95 masks, okay? So that's not good because we want to make 5, right? So it's not going to be 5 times, not going to be a solution to this inequality. Anyways, C equals 4.95. So remember, you solve a system. I'm looking for, well, what does C equal? Okay, if I'm going to solve a system, I need to figure out what my variables in the equations equal. Remember, systems, 2 or more equations, right? You might want to put that in your notes. System, definition of system, 2 or more equations that use the same variables. Okay, so I'm going to want to solve for both variables that work in both equations. So C is going to equal, C is going to equal 4.95. I need to figure out what A equals. I need to figure out what all my variables equal. It says solve a system. It's not going to say solve for the particular variable. What it means in a problem that says solving a system, it means solve for all variables in that system, all unknowns, right? So we got one unknown there because we substituted and got it. Let's get the other unknown. What you got to do for the other unknown is we use this equation to solve for C. Now I got to take this other equation, A equals 2 times C. So I got to take equation number 2. Okay, so remember, step 1, plug what you know about one variable into equation number 1, solve it, then take what you know now about the numerical value of one variable, substitute it into the other equation. So here I got equation number 2, I got A equals 2C. So let's make that A times by 2 times 4.95. Okay, and that's going to tell us the A value for whatever this point is here in the corner of this feasible region back here. So this was 4.95, 9.9. So not quite, can't quite make 5 child's masks and 10 adult masks. It doesn't quite work here, okay? One thing that I didn't cover earlier in class is that you can always check your answers and verify this is right. Of course, I know 4.95 works in this equation, returning a 9.9 for A, because that's what I did here. So I used equation number 2 to solve for A. What I want to do to check your answer, a lot of times in the book, they'll say, hey, check your answers to this system. What I want to do is I want to make sure this works in equation number 1. Okay, so equation number 1 was 14A plus 12C equals 198. And I'm just going to show you that 4.95 and 9.9, they're going to work in that equation here. Okay, so I'm going to take 14 and I'm going to multiply. A is 9.9. I'm getting messy here, too messy, sorry. Plus, we got 12C, so I'll need 12 times by 4.95. Oh, super messy. It looked like an absolute value symbol there, times by 4.95. You with me? Maybe we're just fasting forward right here. Is that going to be equal to 198? And I won't show the work. I'll just do it quickly for the sake of this video. And I'll just show you that, hey, if I got 9.9 and I multiply by 14, so I'm checking that 9.9 in equation number 1. I'm also checking the 4.95 in this equation. So I got 138.6. So I'll remember 138.6. 138.6. Let's see if I can remember that because I'm going to do 12 times by 4.95. Okay, I got that. And I'm going to add 138.6 to that because that's what that was. 138.6 times whatever that was. I did that a second ago. And I get 198. There you go. Okay, so here what our solution set is to this inequality is A is 9.9. That was my x variable. So I got 9.9 and 4.95. I know that's going to be one of my corners of the feasible region. It's not behaving. It's not actually writing out here. Okay? All right, so without further ado, let's get into slide number 8 and beyond. So I'm going to go through these faster because we did it in class. We went through a bit more slowly in class here. Okay, so what you got to do for number 8, you got to sketch in where are the possible regions for these two constraints. Our feasible region. You guys are getting good at that. Where is the freaking feasible region? It's right here, okay? It's where both inequalities overlap, okay? Common solution sets. One thing that I didn't say in class is, look, are negative numbers going to be in these feasible regions? Well, if these were just our inequalities, yes, actually would be, right? Everything below this would be a solution, right? Remember, a linear inequality has got a line, right, which will continue infinitely. Everything on one side of the line would be a solution. Everything on the other side, not a solution. But here, the way Desmos is showing us now, it's only showing us positive numbers. Why is that, right? Why is that? Well, the situation, okay? The situation of the problem calls for you making masks. And can you have negative amounts of masks? No, no. So there's some unspoken constraints, right? That your x's need to be greater than 0. And your y's need to be greater than or equal to 0. I should have said the equal part here. But this is your feasible region. Okay, on the sketch, right, this is what you have to do for homework, so hopefully you're watching this video. This is my feasible region. Type it in. I'll do feasible R, because we're running out of space and time. Sketching where all possible regions, right there. There we go. On the sketch, point to the maximum number of masks we can make from our elastic and child mask constraints. Estimate where these numbers are. Okay, so I got some options here. I'm going to go to my corners of the feasible region. Okay, so I'm going to go potentially here. This is 14, 0. Okay, and then here, does that go through 10.5? It might go through 10.5. I might put a question mark here. Does this go through 10.5? Because if we had, right, if we're just looking at these constraints, I know it didn't work with the elastic and the adult to child mask constraints, But, you know, just for funsies here, we're trying to see, because you could make 15 potentially if that does include, if our points do go through 10.5, like these maybe intersect at 10.5 here, not a point lower than that, then maybe that'll be the most here. Okay, so here and here, these would be the points that we would really care about, because these are sort of maximizing, right? Pushing us furthest to the right on this green graph, and highest in the red graph is here. Furthest to the right here, and then both highest to the furthest to the right, and then high up in the green here. If we can make 15 masks, that would be better than 14. Okay, so it's really between those two. Okay, explain your thinking below here. Okay, sketch it out just like this. Explain why I chose that way. I'll leave that to you. Okay, so the rest of this video, I kind of want to help you solve a system of equations. So you're going to have to do this in tomorrow's classwork, right? You got an asynchronous lesson, just solving systems, just walking through kind of what I normally do in a normal year. Okay, so let's do this. Let's solve a system together. Okay, what am I doing here? Well, I'm going to write my two equations. Remember, what is a system? Hopefully you put that in your notes. A system of equations are two or more equations that share the same variables. Okay, so I'm going to get my equation number 1, which is going to be 18a plus 15c equals 252. Okay, and then I got equation number 2. I got equation number 2, which is that A has got to be twice as much as C. Okay, so we're getting that maximum there, right? High up on the graph would be the borderline, right? The borderline is a statement of equality. This is the line. X equals 2y, right? Or A equals 2C. So, okay, solving by systems by substitution. Do you remember the two ways to do it? Okay, step number 1. Okay, step number 1. It just so happened that I wrote number 1 up here. Step number 1 is we're going to take what we know in equation number 2 about A, and we're going to substitute that in for A up top here. Okay, because A's right here, A's right there. A equals A, but A also equals 2C. So I can replace the A with 2C, and then I can go ahead and solve from here. Okay, so I got, boom, 18 times by 2C. Oh, didn't do a curve, so it doesn't look like multiplication. 18 times by 2C. Oh, I'm not curved again. Plus 15C. Well, nice and slow for you guys right now. Equals 252 because of technology. Okay. All right. So, yeah, I plugged in. Okay, nice. What's good about that again? What's good about substituting in? Well, I have one variable. Okay, so you get good at answering that question. Claire did a good job answering that. Hopefully you do too. Right? Why can't we solve this up top here? Well, it's got two different variables. How do I isolate that variable? Well, I can replace one of the variables with what I know about it. And it just so happens that that's the same variable here as is down there. So now we just have C's in our equation, okay? So let's do it. Let's solve this. Sort of review. This is why kind of over homeworks you're solving so much and trying to give you feedback over homework. We didn't have a unit on solving this year. You know, I'd like to have that normal year, but hopefully you're picking up solving stuff by doing these systems things here. We'll give you feedback too. We'll work with you. Okay, 18 times by 2C is 36C. Oops. This writing is rough. Okay, so this is 36. So now we got to, right, simplify the left side and then combine like terms. So this is 36C plus 15C equals 252. Okay, and now I'm going to combine like terms. So 36C plus 15C, well, we have 36 C's. We're adding another 15 C's to that, so you're just going to do 36 plus 15. That's 51 C's total. Okay, 51 C equals 252. And again, it looks like we're going to get a decimal, okay? Because I know that 51 is not going to go into 252. 50 would go into 250. But let's check it out here. 252, or we divide both sides by 51. Because we have 51 C's. We want to figure out how much 1 C is worth. So 51 C's divided by 51 to tell you what 1 C is. So 252 divided by 5, and we got a very close answer to what we had before. We're going to have to maybe round this. It's 4.94. Look at that. So 5 isn't going to be in the solution set. 510 will be in the solution set here. We got 4.94 C equals, oh, it looks like X. Should do C. Computer's working hard. I don't know if you can hear that. C equals 4.94. Okay, that's step number 1 to solving this. Okay, I got C, 4.94, and A, well, we just got to double it, right? Or we got to double that because, hey, I'm using equation number 2 to solve for my A. I know what C is, and I solve for C up here, so there's no reason to deal with this equation yet, right? Let's deal with the other equation, okay? A equals 2 times by, 4.94. I got that because I already knew what C was right here. Put it in right here. So now I just got to do A equals 2C, so A equals 2 times 4.94. I can maybe do that in my head. Okay, so that's going to be 9.88. Okay, 9.88. So my solution to this system is 4.94, 9.88. So that means that's where those two will intersect. Okay, intersect right here. So we'll graph the borderlines, type the equations below, and I'll show you this here. That's the point of slide number 10, is we're going to do it with y. Okay, we've got to do it with x and y because that's how this graph does it. So we're going to do 18x plus 15c equals 252 plus 15y equals 252. And here we got to do x equals 2y. Okay, remember, you get lines when you just have x and y in an equation and no variables. Okay, so let's check our graph and see if we did it right. You can use it to confirm you did it right. And there we go, I got it. 9.88 for A and 4.94, right? I usually just round it 2 decimal places. So I would say 9.88, 4.94. My solution's correct because where does my solution appear? So this is a good question for you guys. Quick question, a little quiz question. Where does the solution appear on a system of inequalities? Well, it's going to be where each equation intersects one another, where each line in the graph intersects one another, each shape of the graph intersects one another. There's my solution. And it matches up what I had on the last slide right here, 9.88, 4.94. Look at that, the magic of math right there. Solving algebraically, solving using a graph, okay? Reflecting, this is good. I'm going to start my 7th block class in 4 minutes. Very nice. I'm getting this video already done here. And you reflect on this. Here we go. We got our answers. They're put up here. Yeah. Which ones subtract? Let's see. Well, I got my the same answers. Why is it the same answers there? I thought I put 9.8. Now I guess it's rounding for me. So we got like basically the same answers for the first 2. Oh, that's kind of a silly question. Okay, so anyways, which of these solutions satisfy all 3 constraints? Well, yeah, this solution satisfies all 3 constraints. I don't know. Flawed problem. Maybe next year we need to work on a better problem for this. But anyways, we know that at this point it's going to be true for all 3. So you could make 9.9 adult mass and 4.94 child's mass. But that doesn't make any sense either. Like you would probably make 9 adults, or you can make 10 adult masks and 4 child's masks, right? That it was your first answer like a couple weeks ago. It's still maybe the best answer here, okay? Because that's in the feasible region. But anyways, solving systems. Tomorrow, okay, so this is it, right? So this is what you're going to recap, right, in your homework. You're going to head to this. This is right in Google Classroom, right there, right in the assignment. You should be able to find it. Email me if you can't find it. Just talked about solving a system using graphing, the intersection, and then talk about the substitution method. How do you substitute? Use your work, be descriptive, and then you're done with this, okay? Email if you have any questions. Hopefully this video is helpful. I will see you guys on Wednesday. Another assignment tomorrow. We're going to be practicing the substitution method. Bye.